this video, we're going to discuss how to calculate the mean, standard deviation, and variance of the binomial probability distribution. All right, so let's walk through this with an example. So assume that the probability of having a girl is 0.49. Find the average number of girls and families with 10 children. This question also could have been worded as find the expected number of girls and families with 10 children, right? Remember, average or the mean of probability distribution functions is the same thing as the expected value. Right? Actually, you remember from before when we were talking about finding the average or finding the expected value of probability distribution functions, we had discussed this formula, mu, which was also the expected value, so mu, which is also e of x, equals the sum of x times p of x. Right? So in order to use this, we would need this p of x, right? And we would also we would need a table that would show us all the different values of x and all the different values of p of x. Well, x takes specific values. So in our situation, it looks like we're talking about the number of girls out of 10 children, right? Find the probability, assume that the probability of having a girl is 0.49, find the average number of girls in the family with 10 children. So in our situation, x is the number of girls out of 10 children. Right, and x is binomially distributed, so the probability that x equals some particular value, we know the formula for this. We could calculate this. So let's see, p to the x, q to the n minus x. Right, so for all the different values of x that x can take, so x could be 0 girls out of 10 children, 1 out of 10, 2, 3. For all the different values of x, I could calculate p, right? So as a matter of fact, I did that. So I'm going to go ahead and paste that now. So for all the different values of x, I calculated the probability. So I used this function, and I calculated the probability of that value of x. So the probability that x would equal 0 is 0.000 or 0.001. Probability that x equals 1 is 0.011. Okay, and then actually I calculated x times that probability, right? Which is so that's what you see here. I calculated this x times p of x, right? I calculated x times the probability of x, and then I summed it up. I got 4.9. So I calculated that using this formula, 4.9 is the mean. Okay. Well, actually, it turns out that there's you could go through this, but you can see this kind of took me quite some time, and it's time that I spared you by not actually just doing it in the video, right? Because you have to calculate this equation for every value of x. So there's an easier way to do this. You could use the formula for calculating the mean of binomially distributed random variables, and that formula is mu equals, so mu, which is the same thing as the expected value, okay, equals n times p. So the number of trials times the probability of success. So in this situation, that would be 10 trials times 0.49. The probability of success is 0.49. Well, that turns out to equal 4.9, right? So, and this equation actually makes a lot of intuitive sense, right? Because probability of having a girl is 0.49. So on average, you would expect that 4.9 out of 10 children would be girls, right? If the probability of having a girl was 0.5, you would expect on average that if a family had 10 children, they would have 5 girls, which makes a lot of sense. All right, so this equation is really intuitive, and it only works if x is binomially distributed. Otherwise, you have to use this equation. But when x is binomially distributed, then you can just use this shortcut equation of n times p. All right. So similarly, when we're finding the standard deviation for the number of girls in families with 10 children, before we would have used this equation, the sum of x minus mu squared times p of x, right? This is the standard deviation equation that we learned for any discrete distribution function. But if we were to calculate this, this would take a long time to do. So there's a shortcut equation if the random variable is binomially distributed. So if x is binomially distributed, then you can use this equation. Sigma equals the square root of n times p times q. Right? So now this is the standard deviation equation that you can use. All right? So let's go ahead and do that for this question. So the standard deviation then is 10 times 0.49. Now what's q? Remember, q is 1 minus p. So in this equation, this would be times 0.51. Okay, 1 minus 0.49. All right. Let's see if you were to throw that into a calculator. Let's go ahead and do that. So let's clear out our calculator. 10 times 0.49 times 0.51, and then take the square root of that. You get 0.714. 0.714. Okay, so the standard deviation for the number of girls in families with 10 children is 0.714 girl. All right. Let's see, if you were asked for the variance, one more thing I want to mention. So if you're asked to find the variance, then you would just take whatever standard deviation you found and square it, right? Remember, variance is always the square of the standard deviation. So if I just took this number and then square it, I get 0.51. Okay, so the variance is 0.51 for this distribution.